Here is a number that is hard to wrap your head around. 100 billion. That is how many messages WhatsApp delivers every single day. Not in a month, not in a week, every single day. That is over 1 million messages every second, around the clock, without pause. So the real question is not just how does your message reach Jamie? The real question is how does a system handle that without ever breaking down? That is what we are getting into today. But first, let us set the context with a quick example. You send Jamie a message, "Hey Jamie, let us meet at 6 p.m. Your phone drops that message at the nearest WhatsApp server. Think of it like dropping a letter at the nearest post office. That server checks its live directory, finds which server Jamie is connected to, and routes your message through the fastest path to reach him. If Jamie is online, his phone receives it in milliseconds. If he is offline, the server holds it until he recollects. Simple, fast, reliable. That is the single message story. Now forget one message, think 1 million per second. How does the same system handle that without collapsing? The answer starts with one decision WhatsApp made early on. Never rely on a single server. Ever. Because a single server, no matter how powerful, has a ceiling. And when you are handling a billion users, you will hit that ceiling very fast. So instead of building one massive system, WhatsApp built thousands of smaller ones and connected them intelligently. This is called a distributed architecture, and it is the foundation of everything. Here is how to visualize it. Imagine a supermarket with one billing counter. On a normal day, it manages. But on a busy Sunday, the queue stretches out the door and the whole system grinds to a halt. Now replace that one counter with 50 counters running in parallel. Same number of customers, but the load is split evenly. Everyone moves fast. No counter is overwhelmed. WhatsApp applies this exact idea, but at a global scale across thousands of machines. Every user is connected to a nearby server based on their geographic location. A user in Mumbai connects to a server in the Mumbai region. A user in London connects to a server in Europe. This is not random. It is deliberate load distribution. Each server is responsible for only a fraction of the total users. No single server sees the full traffic. The pressure is always shared. But distribution alone is not enough. The servers also need to talk to each other efficiently. WhatsApp maintains a live routing layer, a real-time map of which server every active user is connected to at any given moment. When a message needs to travel from your server to Jamie's server, the system already knows the fastest path. There is no searching, no broadcasting, no trial and error. It is a direct, optimized handoff. This is what keeps delivery fast even as volume scales into the billions. Now, what happens during a traffic surge? New Year's midnight, a major breaking news event, a viral moment where half the planet is messaging at the same time. This is where elastic scaling comes in. WhatsApp's infrastructure is designed to detect rising load in real time and spin up additional servers automatically to absorb the spike. When the surge passes, those extra servers are wound down. The system breathes, expanding and contracting with demand. No human intervention needed, no crash, no slowdown. There is another layer worth understanding: data centers. WhatsApp does not run everything from one location. Their servers are distributed across multiple data centers on different continents. This serves two purposes. First, it keeps servers physically close to users, which reduces the time it takes for a message to travel. Second, it builds redundancy into the system. If one data center has a problem, traffic is automatically rerouted to another. The system does not go down, it adapts. And then there is the message queue, an often overlooked piece of the puzzle. When messages arrive faster than they can be processed, they do not get dropped. They enter a queue and are processed in order. Think of it like a well-managed waiting line. No message is lost. No message jumps ahead unfairly. The system works through the backlog steadily, even under extreme load. So when you look at all of this together, geographic distribution, live routing, elastic scaling, multi-region data centers, intelligent queuing, you start to see what actually makes WhatsApp handle 100 billion messages a day. It is not one giant powerful machine. It is thousands of coordinated smaller systems working in perfect sync. The strength of the architecture comes from how it is spread out, not from how big any single piece is. That is the real engineering story behind WhatsApp. Not just that your message reaches Jamie in milliseconds, but that it does that simultaneously for a billion other conversations happening at the exact same moment, without the system ever flinching. If you found this interesting, subscribe and hit the bell. Every week, we break down how the technology you use every day actually works. No jargon, no fluff, just the real story. Drop a comment and tell me which app or system you want to understand next. See you in the next one.